All right, welcome back to this class. Let's consider colloidal dispersion. A colloidal dispersion is a heterogeneous mixture or a type of mixture that is neither a liquid solution nor suspension. That is, it is neither a true solution nor a suspension. It means its properties lies between a solution or and a suspension. That is, it is intermediate between a true solution and a suspension, meaning that we cannot distinctly call it a true solution nor call it a suspension. Examples of such mixture are the following: natural milk, blood, gum, glue, smoke, etc. Now, it should be noted that the particles that dissolve in a colloidal dispersion are known as colloids. Colloids are bigger than crystalloids. Crystalloids are the dissolved particles in a true solution. That is, crystalloids are the solutes that dissolve in a true solution, but colloids are the solutes that dissolve in a colloidal dispersion, and they are very much bigger than crystalloid. But notwithstanding, colloids too can also not be seen with the naked eyes, just like crystalloids, but it can be viewed with microscope. Although colloids are bigger than crystalloids, but they are smaller than sediments. Sediments are the particles in suspensions, such as sand in water. Sand is a sediment inside suspension, but colloids are smaller than sediments because at least we can see sediments with our naked eyes. Now, it should also be noted that colloidal dispersion are always opaque in nature, and this is responsible for why they cause Tyndall effect. Tyndall effect is the scattering of a beam of light when it is passed through a colloidal dispersion. That is, the scattering of light when it passes through a colloidal dispersion. So let's see an image that displays Tyndall effect of colloidal dispersion. Consider the image above. You can see the beam of light successfully passes through a true solution without scattering. So that means for a true solution, no Tyndall effect. But on the other hand, in a mixture of water and milk, this is a colloidal dispersion. So the light scatters when it passes through this because milk is an opaque substance. It is not transparent. That is why we can't see through milk anytime we look through milk. We cannot see the other side. That is because milk is opaque and it is a colloidal dispersion. Now, let us see the classification of colloidal dispersion. Generally, colloidal dispersion can be classified into three. We have sol and gel, emulsion, and aerosol. Now, let us consider sol and gel. Now, I'm going to start with sol. Sol is the dispersion of solid particles in a liquid. A good example of that is starch solution. So what we observe when we pour starch inside water is that there will be concentration of the water after stirring it. Now, but when salt becomes more concentrated, that is very concentrated, it becomes gel. In a gel, the solute is more dominant than the solvent. Whereas in salt, the solvent is more dominant than the solute. Example of gel is hot water starch and natural honey. Next, we talk about emulsion. Emulsion is the dispersion of a liquid in another liquid. Example of such colloidal dispersion are natural milk and paints. So, natural milk is the dispersion of butter fat inside dilute sugar solution, while paint is the dispersion of color solution inside water or alcohol. Next, we talk about aerosol. Aerosol is the dispersion of solid or liquid in a gas. Examples are cigarette smoke, which is a dispersion of tobacco particles in air. Then we have fog, mist, dew, and cloud. All of these are dispersion of water vapor in air. We have insecticide, which is a dispersion of liquid particles in air. We have lather, foam, or gas bubble. These are dispersion of air in liquid. Thank you for viewing this. God bless you.